Okay, so let's talk a little bit about lab number 10. What are we doing in today's lab? What are we doing in lab 10? What are we titrating? So what are we titrating in lab 10? Yep, so lab 10 is the vinegar titration. And as with any titration, titrations are centered around a reaction between, in this case, as it's an acid-base titration, it's a titration centered on the reaction between an acid and a base. In this case, our acid for this experiment is CH3CO2H, which is acetic acid. So vinegar is a solution of acetic acid in water. So acetic acid, aqueous. And what is the base that we're using in our reaction? What base are we using? What was that? Sodium hydroxide, exactly. So fundamentally, our titration reaction, in this acid-base reaction, we are titrating our acetic acid with our standardized sodium hydroxide that we know the concentration is about 0.15 molar. Just like our titration and standardization with KHP, what is our mole ratio? What's our ratio of molecules of sodium hydroxide to molecules of acetic acid? 1 to 1. So this is another 1 to 1 acid-base titration. So the acid and base will react, and you'll make sodium acetate, which is CH3CO2Na, and you'll also make water. Okay, so this is the titration. This is the reaction that underpins the titration we'll be doing today. Okay, now, in terms of practicality, in terms of the actual practical amount, so we have our Erlenmeyer flask. We have our Erlenmeyer flask. What goes into our Erlenmeyer flask for this titration? What are we going to put in our Erlenmeyer flask? What was that? Vinegar, yep. What volume? How much? How much of the vinegar are we titrating? How much? And this is really important because you don't want to, how much? What volume of vinegar are we titrating? Let's make sure we're 100% clear on that. 25 mils. So we're going to transfer 25.00 milliliters of vinegar solution. So we're going to use a volumetric pipette. Okay. Then, in addition, we are going to add what? In order for us to visualize the end point of our acid-base titration, what are we going to add into our Erlenmeyer flask? What's our indicator? Phenolphthalein, exactly. And this is our indicator. If you forget the indicator, you will not be able to visualize the end point. And as I discussed last time, you won't be able to see when the acid and base are in an equimolar are in a stoichiometric ratio, or in that 1-to-1 ratio and have completely reacted. The only thing you can see is when you have a little bit extra indicator, when you have a little bit extra sodium hydroxide, your indicator will change color. That's the pink color you observe, and that's known as the end point. If you forget the phenolphthalein, you won't see anything. And that's turning into just a waste of sodium hydroxide. Now, when I say approximately 0.15 molar, where do I get the exact concentration? Do I know the exact concentration of my sodium hydroxide? Did we figure that out last time? The concentration. What sodium hydroxide are we using? I'll give you a hint. We have it in the window over there. Do we know, and did we titrate this sodium hydroxide, and do we standardize this sodium hydroxide last lab? Yes. So you're going to get the exact concentration from your lab number 9. Okay? And I'm more than willing to look through your calculations just to make sure you have that concentration correct. Now, with that said, once you have your vinegar solution prepared, so we have our vinegar solution prepared. So we have our 25 mLs of vinegar. What are we going to put into our burette? What are we going to put into our burette? What is going to go inside our burette? What solution are we going to fill the burette with? Sodium hydroxide. So you're going to fill this with your approximately 0.15 molar sodium hydroxide. Okay? Do not put the vinegar solutions into the burette. Just always making sure we're clear on what goes where. Okay, then what you're going to do is you're going to add and you're going to titrate and add the sodium hydroxide dropwise until you see a color change. And once you have the color change, so let me write out what data you're going to collect. So you're going to record the volume initial in your burette, which is the initial reading in your burette. You're going to titrate and add the sodium hydroxide until you reach what is known as the end point. So now we have our exact same setup. And you're going to record the final volume after your solution undergoes a color change and you see the faint pink color. So we call this the end point. Can we figure out the volume of sodium hydroxide dispensed? Do we know how much we've dispensed if we know the burette reading before and after? Yes. So what we're going to do now is we're going to calculate the volume. So the volume of NaOH is equal to volume final minus volume initial. Okay? We know that the molarity of sodium hydroxide is approximately 0.15 mole. Your exact number may be a little bit different. I'm going to use 0.15 just so that way we have a reference to go through for our calculations. We can now calculate the moles of sodium hydroxide if we know the molarity and the volume, because remember, this big M is saying we have 0.15 moles of NaOH per every 1 liter. And if we know the volume, can we calculate the moles? Yeah. So the volume of the moles of NaOH are equal to the volume of NaOH times the molarity of NaOH. With the key feature being this volume of NaOH needs to be in what units? Liters. Okay, wonderful. Now, when we discussed this acid-base reaction, what is our ratio for moles of NaOH to moles of acetic acid at the equivalence point? What is our ratio? 1 to 1, right? So we're going to use this stoichiometry. We know that the moles of acetic acid are equal to the moles of NaOH times, we know that we have 1 mole of acetic acid per every 1 mole of NaOH. Now, although you can say, oh, that's 1 to 1, we're just multiplying by 1. The moles are going to be the same. Yes, that's true. It's not always true for every single acid-base reaction. And that's why I'm showing you this step by step. And this is how the units actually cancel, right? So the moles of acetic acid in this case are equal to the moles of NaOH dispensed. From there, we can calculate the concentration of acetic acid. And the concentration is equal to the moles of acetic acid over the volume of vinegar dispensed. So this is the concentration in vinegar. Okay, is everyone following so far? Does this make sense so far? So we know the moles, so we can calculate it by just taking the moles of NaOH. And then what are we dividing by? Do we know the volume of vinegar dispensed? How much did we dispense? 25 mLs, right? Remember when I go all the way up here? This is why we always ask these very specific questions, because they're needed to complete the calculations. Okay, So we're going to divide our volume of NaOH by 25.00 milliliters times 10 to the negative third liter per mil. Remember, molarity is moles per liter. So you're going to need to convert this 25 mils into liters. Does that make sense? Okay. So perfect. We are at the stage where we have figured out the concentration of acetic acid. Let's now take a slightly different tact. If we want to figure out and we want to report, we really want to report the mass percentage of acetic acid, CH3CO2H. Let's suppose we wanted to report the mass percentage of acetic acid in vinegar. What two pieces of information will we need if we want to report mass percentage? What is the part? What's the part we're looking for? Let me rephrase. So you have a solution of vinegar, right? So we have a solution of vinegar. And a small percentage of this solution is going to be acetic acid, and the remaining mass will be water, right? So then in order to figure out the mass percent of acetic acid, what is the part that we're caring about? What mass do we put on top? The mass of acetic acid, exactly. So we need the mass of acetic acid. And then what is the total mass? What is the entire solution that we're studying? What do we call it? It's a sample of vinegar, exactly. So we need to figure out the mass of 25 milliliters of vinegar, right? Because that is the sample that we're titrating, right? Okay. So with that established, let's now focus on how we can figure out these quantities. Well, we can just take our Erlenmeyer, add some acetic acid, and weigh it. That's one way of doing it. You're not allowed to do that in this lab. You're going to have to do it using a slightly more friendly method. And what we're going to do is we're going to first, in order to calculate the mass of the vinegar, we're first going to need to find the density. Okay, so the way that you get the density is, and I'll show you this via pictorial format, you're going to take a beaker and you're going to record the mass of the beaker. Everyone okay so far with this? Now we're going to determine the mass of a known volume of acetic acid. So to this beaker, we're going to transfer what volume of our vinegar solution? What volume? And this is in your procedure. When you're determining the density, what volume are you going to use? Oh, okay. Allow me to revise. The procedure doesn't want you to go through the density. You can, if you want, take the mass of a beaker, dispense a known volume of vinegar, and then record the mass at the end. This is a common method if you want to preserve material, and you can in turn calculate the density by taking the mass over the volume. In this experiment, they've actually given you a pass, and we've made it a little bit easier on you. You're going to take your Erlenmeyer, record the mass of the Erlenmeyer. Then you're going to add your known amount of vinegar, of acetic acid solution. And how much acetic acid are we always going to add before our titration? How much acetic acid did we add? Oh, how much? 25. So we're going to take 25.00 milliliters of our vinegar solution or our acetic acid solution. And then what you're going to do is you're going to put that same Erlenmeyer containing your solution on the balance and record the mass of the Erlenmeyer plus your vinegar. And from this, if we take the difference, we can figure out the mass of our vinegar, which is 25 mils, by taking the mass of the Erlenmeyer plus the vinegar minus the mass of the vinegar. Oh, minus the mass of the Erlenmeyer, sorry. So this is weighing by difference to figure out the total mass of vinegar solution that we're titrating. Does that make sense to everyone? Okay, so we have checked off the mass of 25 milliliters of vinegar. Let's now focus on the mass of acetic acid. Let's focus on that. So to figure out the mass of acetic acid, the mass of CH3CO2H, how do we calculate mass? What quantity do we already know from the result of our calculations? What quantity have we figured out? We figured out the concentration, right? What else have we figured out? Let's look. So what have we figured out in our calculations that allows us to calculate the mass of acetic acid? What was that? The density allows us to get the mass of the whole solution. So yes, that's part of it. But specifically with regards to the mass of acetic acid, do we know the moles of acetic acid from our calculation? Yes. And can we calculate mass from moles? Yes. So then, let's do just that. The mass of acetic acid is just the moles of acetic acid times the molecular weight. Okay, so we take the moles of acetic acid times the molar mass. And does someone have an approximate molar mass for me for acetic acid? Approximate here, ballpark. 60.5, exactly. Okay, and we know we can get the mass of our vinegar solution that we titrate via difference. And all we have to do to calculate the mass percent is combine these two pieces of data together. So the mass percent of acetic acid in commercial vinegar is equal to the moles of acetic acid times the molar mass, which is 60.5 gram per mole, divided by the mass of the vinegar that you titrated, times 100%. In general, you should get a mass percent of approximately 5%, as that is the typical mass percentage in most commercial vinegar solutions. Your value may be more, it may be less, but this is just a ballpark. If you get a mass percentage of 30 to 50, you're likely doing something wrong or you missed a conversion factor. So that's all the information you actually need to complete this lab. Are there any other questions that I can address for this laboratory? Any other questions on the calculations? Yes. So the volume of vinegar is in terms of why is it 25 or where do we get the number? So let's go through it from scratch. So we have the mole-to-mole ratio in our chemical equation. At the equivalence point, which is approximately the same as the end point, we know that if we take 25 milliliters of vinegar and we titrate it with a known volume of 0.15 molar NaOH, we can figure out the volume of NaOH by just reading the burette. We can figure out the moles of NaOH by taking the molarity times the volume. And then if we're solving for the concentration of acetic acid, we take the moles of acetic acid calculated over the volume of the solution dispensed. In this case, we know we took it in how many milliliters of our vinegar solution. How much did we dispense into our titration? 25, exactly. So M1V1 equals M2V2 only applies for dilutions. For titrations, it's better to calculate the moles, use the mole-to-mole ratio, and then calculate molarity by taking the moles of your species divided by the volume. Does that make sense? Okay. Are there any other questions that you would like to address? Are there any other questions? What? Oh, because I turned off one set of the lights. Now, just as a side note here, on your pre-lab question 1, you were asked to calculate the volume of acetic acid solution necessary to neutralize 25 mils of 0.1 molar NaOH. Now, the reason why this question is especially relevant, and we need to bring this up right now, is that if you try to titrate a full 25 mils of vinegar solution, you're going to run into some problems. So we're going to need to modify this procedure to accommodate the concentration of NaOH that we have. Okay? So we're going to do this together, and I'm going to ask for your input here. So looking at the pre-lab question number 1, I would like you to tell me what volume of vinegar, what volume of acetic acid have we calculated? What approximate volume did you get? I just want to check that we're in the right ballpark for the pre-lab. Would anyone like to volunteer? Don't be shy. This is an open moment where we're just talking about what we've calculated so we can go over it as a class. I'm sure if you had problems with the calculation, other people will, and I just want to check before I let everyone loose that our numbers are matching and that they're reasonable. So about what volume of vinegar are we titrating actually? What was that? So let's see. So 21.7. Any other calculation results for this?
I think I got 3, but I messed it up.
Okay, about 3.0 mils. So this value of around 3.0 is closer to the amount that you're actually going to be titrating today. So let me showcase this and let me show you how this works. And this is what how you're going to revise your procedure to use the correct volume of vinegar in the titration. So let me show you this. Now, the reason why I save this to the end is that your pre-lab is necessary in order to complete the laboratory. And the reason why we're going over the calculations now is so that way we don't have everyone titrating 25 mils of acetic acid and wondering why it's taking them literally 200 mils of sodium hydroxide. So let's stave off that issue and let's showcase the calculations. So we know that we have a 5% solution of acetic acid, right? And we know the density is about 1 gram per mil. Our goal is to neutralize 25.0 milliliters of 10 molar NaOH, okay? So this is the information that we're provided. So first we're gonna go from the volume of NaOH to the moles of NaOH. And our end goal is to determine the volume of the vinegar solution. Where do we get the volume of the vinegar solution from? Given that we know the density, where are we going to get the volume of the vinegar solution from? If we want to get the volume and we know the density, what quantity are we going to go from? How do you get volume given the density? What do you input? Density relates what two quantities? Mass and volume. So if we want to get the volume of vinegar, what do we need to start from? Mass. So we're going to use the mass of vinegar. And now, the moles of NaOH are related to what in our chemical equation? They're related to the moles of what? What is the sodium hydroxide reacting with? Acetic acid. So we can go from moles of NaOH to moles of acetic acid. And then from moles of acetic acid, we can go to the mass of acetic acid. So it's nothing that we haven't seen before in our unit conversion exercises, but this is a relatively multi-step conversion. So starting off, we have 25.0 milliliters of sodium hydroxide. What is our molarity? How many moles of sodium hydroxide do we have per liter? Just reading off from the problem. 0.1. Yep. So we know that we have 0.1 moles of NaOH per 1 liter. We're going to need to convert this milliliters into liters, and we know we have 10 to the negative third liter per mil. So currently, we're at the moles of NaOH. What is our mole to mole ratio? What is this titration? Is it a 2 to 1, 3 to 1, 1 to 1? What is it? 1 to 1. So we know from our mole to mole ratio, we have 1 mole of acetic acid per 1 mole of NaOH. Wonderful. How do we go from the moles of acetic acid to the mass? molar mass. And we know that we have 60 grams per 1 mole of acetic acid. Now, this is where the mass percentage comes into play. This is where the mass percentage comes into play here. Okay, so at the end of this string, okay, let's keep going now. From the mass percentage, we know we have how many grams of vinegar per how many grams of acetic acid. So our mass percent is 5%. This is a 5% acetic acid solution. So how many grams of acetic acid do we have per how many grams of vinegar? What was that? You don't have to subtract. Just write it off like your typical mass percent conversion. So how many grams of acetic acid do we have in 100 grams of vinegar? Does this look a little more familiar? How many grams of acetic acid do we have in 100 grams of vinegar? 5, exactly. Because what's the mass percent? What's the mass percent? 5%, exactly. So this allows us to go from the mass of acetic acid to the mass of vinegar. And then finally, if we're going from the mass of vinegar to the volume, in 1 milliliter of vinegar, we have how many grams? What's our density? 1, exactly. Okay. So now let's punch this into our calculator. Let's punch this entire expression into our calculator, and let's make sure we're all on the same page. So we have 25 times 0.1 divided by, let's do this, yeah, let's punch this into our calculator together. So we have 25 times 0.1 times 1 EE negative 3 times 1 times 60 times 100 divided by 5 times 1. And that gives us exactly 3.00 mils. So in all of our calculations, this 3.00 mils is the volume of vinegar that you're going to titrate. No more, no less. You want to titrate about 3 mils. Does that make sense? So in your calculations, as we've discussed, for the volume of vinegar, you're going to use, instead of the full volume, you're going to use 3 mils. And you're going to need the mass of 3 mils of vinegar. So then all of your calculations are going to be modified to reflect the fact that you're titrating 3 mils of vinegar. Is everyone clear on what we're doing today, and is everyone clear on the amounts of each reagent we are using? You're going to titrate and do multiple runs of 2 different commercial vinegar samples. And for those who have not finished their unknown acid, you'll finish the unknown acid today. Yes, you'll have more than enough time to complete your titrations. So at this time, you're welcome to begin. I'll turn the lights back on. You're free to get your bottles from the window, and you're free to put on your safety goggles as chemicals are being handled today. So please make sure your goggles are on and your bags are stored, and you're welcome to begin.